on that whiteboard, it says P equals mass times velocity. Mass meaning the weight of a person and velocity meaning the speed at which you're going. So here's an example. So say Teresa and I are bumper cars and we both have the same mass. She is not moving, but I'm moving at 10 meters per second. So while moving towards her and hitting her and crashing into her, we essentially become 1 unit. And because of that, we had to, due to the energy conservation law, we had to divide my momentum in half, my velocity in half, so that we have equal energy.
Okay, so next I'm going to be talking about gravitron. So if you guys are familiar with gravitron, it's the ride that keeps you spinning in a circle, and at a certain point you hit a speed so great that you start to feel weightless. The reason that works is because of the centripetal forces working on you, the force of gravity, and also the friction force from the centripetal force. So we take a look at the circle right here. There's some circle right here, and you're on the edge, and then there's actually a force pulling you toward the center the entire time. That's the reason why you keep changing directions as you're going through the circle. Instead of just shooting off straight, it's because there's always a force bringing you back in that circle. So we take a look at you as a person, that means that same force is pulling straight out. There's a force bringing you down. That force that's bringing you down is the force of gravity. I'm sure you guys are all familiar with the fact that we stay on the ground and we don't just start floating. It's because gravity is always trying to pull us down. It's the mass of the earth just bringing us down. And then, as I was talking about, there's a friction force going up. So if there's a force going toward the center, a force trying to bring us down, there's a force that's going to go against both of those, and it's going to go up, and that's the force of friction. So as this force becomes so big, because you're moving faster and faster, the force needs to get bigger and bigger. This force becomes bigger, and at a certain point, these two forces cancel out, and you get the feeling that you're weightless, which is what comes from gravitron.
So now I'm going to talk about roller coasters. How many of you guys like roller coasters? Pretty fun. So the main two energies behind roller coasters are gravitational potential energy and kinetic energy. Gravitational potential energy is basically just the force of gravity that's pulling you down, and kinetic energy is the energy of motion. Say that you're at the top of the roller coaster waiting for the ride to fall, and you're just waiting there. That's gravitational potential energy. And then as you start moving, it converts into kinetic energy. So it's just like that, from gravitational potential energy to kinetic energy. And if you look at the handout that you received, the equations for gravitational potential energy and kinetic energy are both on there. You can create your own roller coaster. And
So now we're going to have a really quick quiz kind of thing. So if you can tell me the equation for momentum, I'll give you popcorn right now. So, yes. Yes.
Alright. So thank you guys for joining us at the Cirque du Soleil. You can just make your way down to the old pool area. Woo!